Today we will see the simplex method of for the solution of LPP in operations research. In this video we will study first what are the some important points, then we will study steps to apply for simplex method to solve LPP. We will also study the solution by using software. Simplex method you will find is the most easy method, and the best advantage is that it can be used for any variables. It can be used for 2 variables or it can be used for more variables also. It can be used for both maximization and minimization type. Similar to the graphical method, there is no limitation for the constraint equation. Let us try to understand some of the important terms used. One is the slack variable. Whenever the equation is of less than type, in order to convert the equation into equality, we have to add the slack variables. Slack variables represents unutilized portion of the given resources. Whenever the constant equation is of greater than type, still we need to consider the surplus variables in order to convert the equation into an equality, and it represents the additional resources used above the over limit. In order to form an initial solution, we assume x1 and x2 as 0 for starting solution, and in that case some of the other variables in the equation will have a non-zero value, and the variables which are having non-zero value are called as basic variable. In order to apply the simplex method, we must check these 3 checkpoints. First, we need to confirm whether equation has been converted into equality. Second, we have to confirm the right hand side of the equation must be greater than 0, and third, we have to confirm that there must be at least one basic variable which is having non-zero value. We will solve the same problem which we have solved in the previous session by graphical method, which is having one objective function and 3 constraint equations. Now, all the constraint equations are of less than type, so we have to add the slack variable as shown. S1 is added in equation 1, S2 is added in equation 2, and S3 is added in equation 3, and all these S1, S2, S3 represents the amount of unutilized resources. When we add some slack variables in the constraint equation, all these are also added in the objective function, but as this represents unutilized resources, they are not going to contribute towards the profit. So, their coefficient we have to assume as 0 S1, 0 S2 and 0 S3 in the objective function. Now, we need to write the initial simplex table. For writing the initial simplex table, first we have written all those variables x1, x2, s1, s2, s3. Then we have also added their values in the objective function. X1 coefficient was 400, x2 was 300, and all s1, s2, s3 was 0. Then we have written the first equation 3x1 plus 2x2 plus s1 is equal to 120. Which is having maximum positive. So, here this Cj minus Zj is 400 having maximum positive value. So, this becomes our entering variable. Now, x1 is going to enter into the solution, but when x1 has to enter, one of the variable has to leave. Now, which variable has to leave? It depends upon the ratio. So, based on this coefficient in this pivot column, by dividing to this, we will divide the solution by pivot column coefficient. For example, 120 divided by 3, we get 40, 150 divided by 3, we get 50, 240 divided by 8, we get 30. So, minimum ratio is a criteria for deciding the leaving variable. So, we know that now x1 is going to enter into the equation, now s3 is going to leave. Let us construct one more simplex table for the after this. Header row is the same, rest all format is same. Now, what we have done is x1 has entered into solution. So, this becomes our new pivot row. So, this new pivot row is obtained by dividing this previous row by this pivot element. Pivot element is 8. So, divide this entire row by 8 and you will get this new row. So, 8 by 1 is 8, 6 by 8 is 8, 0 by 8 is 0, 0 by 8 is 0, 1 by 8 is 1 by 8 and then 240 by 8 is 30. Once this new pivot row is obtained, other rows can be obtained by using the formula new row is equal to old row minus pivot column coefficient into new pivot row. For example, new S1 is obtained by old S1, this is old S1, then 3 is this pivot column coefficient. So, old S1 minus this pivot column coefficient into new pivot row. If you do this calculation, you will find these values will obtain. Similarly, old S2, this new S2 is obtained from old S2 by using again the same formula, old S2 row minus old pivot column coefficient which was 3 into new pivot row is this x1 row. And after solving this, again you have to obtain the value of Zj. Value of Zj is simple to obtain. What we have to do here is to obtain the value, see 0 into 0 plus 0 into 0 plus 400 into 1, okay, that becomes 400. Similarly, we have to multiply by 0 into 2 by 8, 0 into 22 by 8 plus 400 into 6 by 8 will get 300. So, all the values are obtained like this, and then we obtain Cj minus Zj. See, Cj was 400, Zj is 400, 400 minus 400 0, 300 minus 300 0. Now, we will find Cj minus Zj will have either 0 or negative values. So, we know that when we perform an optimality test, the optimality test is when Cj minus Zj is 0 or negative, we have to assume that optimal solution is reached. So, we need not have to continue further for new iteration. X2 is equal to 0 and Z max is equal to 12,000. So, it is the same solution what we had obtained by graphical method. So, by changing the method, optimal solution does not change, optimal solution remains same. Now, we will see how to make use of the software to obtain the solution of LPP by simplex method. Simplex method is one of the method to solve LPP. So, click on LPP, go to input screen. We have already studied in the graphical method. The decision variables are 2, the constant equations are 3 and the problem is of maximization type. So, these are the inputs you need to give initially before we solve this question. Then press tab. If you press tab, the grid will appear. In this input grid, you write down the coordinates of x1 as 400 and x2 as 300. Method is very much similar what we have studied it for the graphical method. Put the coordinates of x1 and x2, it is equal to 120. Second equation, 3x1 plus 5x2 is less than or equal to 150, and the third constant equation is 8x1 and 6x2 is less than or equal to 240. The non-negativity constraint is taken care by the lower bound, that is 0 0, and upper bound is infinity, no limit on the upper side. Okay. If you want to save the data, you can save. Go for solve menu. In solve menu, you have to select as algebraic method. Algebraic method is nothing but the simplex method. Here we will go for the iteration. and for maximization type we will select all slack starting solution. Go to output screen, you will find this is what very much similar to the initial table what we had obtained. After this you have to do the next iteration, and when you click on the next iteration you will find the next iteration is an optimal solution. That is also what we had confirmed when we solved it manually, and you will find the value in the equation of z there are either 0 or negative. So, value of z is 1200, value of x1 is equal to 30, and there is no x2 in the solution because x2 is not a basic variable and hence it is having value equal to 0. So, same solution is obtained by software also. In our next video we will see few more techniques of operations research to solve many other problems like assignment or project network. Thank you very much. Keep watching this video.